Richard Conert has been a systems engineer at LASP for 30 years. His mentor was one of the original directors of the lab when it began shortly after World War II.
So the U.S. recovered a bunch of V2 parts and rocket parts from Germany. What the government learned was that it wasn't industry that was making these rockets, it was the university scientists and whatnot.
The U.S. government saw the value in developing rockets, and they tried to get universities involved by offering certain incentives.
They would have the university scientists engaged by offering them rides for their experiments into space.
LASP started out in 1948 by a team of CU Boulder physicists. Their first project was a biaxial pointing control system, which helped stabilize rockets from spinning excessively.
The initial name of the laboratory was the Upper Air Laboratory, the UAL, and its primary objective at that point in time, besides developing the pointing controls, scientifically was to determine the extent of the atmosphere.
In 1965, the Upper Air Laboratory began planetary research and took the name we know today. In 1967, CU's Laboratory for Atmospheric and Space Physics sent instruments on board NASA's Mariner 5 to Venus. Its mission? To measure the magnetic field, pressure, and temperature of Earth's sister planet. But it was in 1969 when LASP first went to Mars. Back then, the lab built the ultraviolet spectrometers that were carried by Mariners 6 and 7, which made flybys of the red planet.
The primary goals of the Mariner flybys were simply to determine whether or not Mars had an atmosphere and some of the constituents of the atmosphere.
What the Mariner mission showed is that Mars does indeed have an atmosphere, composed mostly of carbon dioxide. There were more space missions to come. Starting in the 1970s, LASP assisted NASA's Voyager missions, exploring the outer solar system, and recently, with the Kepler spacecraft, taking surveys of stars to find exoplanets that orbit their parent stars in what is called the habitable zone, where a planet can be capable of sustaining liquid water. Finally, there's the unique story of LASP students who built an instrument that was launched in 2006 for Pluto. The Venetia Burney Student Dust Counter is an instrument on board NASA's New Horizons spacecraft. It will reach Pluto in 2015, but in 2010, the Student Dust Counter became the record holder for the most distant functioning space dust detector ever in space. Despite these missions to the far reaches of our solar system, LASP scientists and engineers are still drawn to the red planet. MAVEN is perhaps their most ambitious project. But before it can find out why Mars lost most of its atmosphere, MAVEN first has to get there. Designed and built in Colorado, flown to the Kennedy Space Center in Florida, and now poised for launch atop an Atlas rocket, scientists and engineers are making sure that MAVEN will leave Earth without a hitch. Reporting for CU Science Update, I'm Nicolas Altieri.